If you want to know whether the water on the table is still hot, the simplest way is to touch it with your hand. But if you want to know its exact temperature, human senses quickly reach their limits. So you come up with an idea. Use the principle that air expands when heated and contracts when cooled. You make a glass tube and observe how the liquid inside rises and falls to read the temperature. However, this method is heavily affected by air pressure, making the readings highly inaccurate. To eliminate atmospheric interference, you seal the top of the glass tube and even replace the liquid with more sensitive mercury. Yet the design is still imperfect. Once the thermometer is removed from the water, the mercury column drops back down almost immediately, and the true temperature is lost. But this doesn't stop a clever mind. You add a bulb at the bottom of the glass tube to store the mercury, and make the measuring tube extremely narrow to improve precision. The most ingenious detail lies at the junction between the bulb and the thin tube, a constricted curved passage known as a choke point. During measurement, expanding mercury is forced through this narrow passage and rises up the tube. But once the temperature drops, the mercury contracts and becomes trapped above the choke, unable to flow back into the bulb, locking the highest temperature in place. Now you can read the result at your leisure. Afterward, all it takes is a firm shake. Using inertia, the mercury flows back into the bulb, ready for the next measurement. Congratulations! You've just invented the mercury thermometer.